Our project is 3 algorithms for machine learning, focusing on predictions from demographic data from a US census. The problem is how to guess whether a person made more or less than $50,000 in the year of the census. We're provided with a training dataset of 30,000 people with which to teach our algorithms, and a 15,000 data point set with which to test them. The 3 algorithms that we are using are naive Bayesian classifiers, regression, and clustering. My machine learning algorithm is naive Bayesian classifiers. This algorithm uses the relationship between prediction values and the desired output variable to alter underlying probabilities. In this case, a person about whom you know nothing has only a 25% chance of making more than $50,000. Each time you know more about them, their sex, their field of work, their age, you can refine your guess for whether they're above or below the cutoff. For example, having more than $10,000 in capital gains makes a person extremely likely to have made more than $50,000 total, while other variables, like sex, can have more moderate effects on the probability. Ultimately, probabilities are calculated by reading in the training set and finding a conditional probability that a person had a certain characteristic, given that they made the $50,000, and then using these so-called multipliers in a final equation to determine the likelihoods for the future people who come in the testing set. In the end, the naive Bayesian classifiers was extremely accurate. It had 84% accuracy in the testing set and determined people's income bracket to a very good extent.
My algorithm was linear regression, which is essentially just a multidimensional line of best fit for a dataset. Specifically, we'll be using a least squares method to predict whether or not a person made over $50,000. For our project, we decided to use the Frisch-Waugh theorem, which states that one can regress the residuals of the regression of variable 1, the desired variable which you want the coefficient for, onto all of the other variables, and regress those residuals onto the residuals of the regression of y, the y variable, onto all the other variables, and then take the OLS coefficient of this as your final answer. The base case of this recursive function would just be the case of one regressor, for which there is a set formula for calculating the coefficient. The input for this function is always a list of objects of type regPerson, where regPerson is simply our overarching person class converted so that each of the categorical variables is converted into a binary variable. Unfortunately, this function resulted in many layers of recursion, making the runtime too long to use all 100 regressors. However, the good news is that even only using a handful of regressors, the function guessed around 80% of a small sample size correctly.
This version of the prediction algorithm uses clustering. The attributes of each person are mapped to a number via dictionaries and the normalized function. People become points on an n-dimensional plane, n being the number of attributes. By choosing k centers, we form k groups by putting people into a group that is closest to that center. We use the distance, min-distance functions to find the distance between points. We then cyclically reevaluate the centers based on the people in the group via the centroid function. Then we regroup the people and start over again in regroup. Moving on to probabilities. The members of each group lend the group a probability of whether or not they will make more than $50,000 in a year. When we get a new person, we map it to a particular group based on, again, the distance function, and then use that probability to make a guess as to whether or not the new person will make over $50,000 a year. In the meta module, we can use all 3 algorithms in a meta algorithm. This can be written out to a file via the metaPredict file function, which predicts whether or not a person will make over $50,000 for each person in a file, and then writes it out to a new file called meta results. We can see here that first it writes whether or not the person actually made over $50,000, followed by whether the meta algorithm was correct, and then each individual algorithm, the clustering, regression, and Bayesian. There's also a command line user interface where you can enter the age, final weight, all of the attributes for people. then the meta algorithm will make a prediction.